All right, well, in case you are absent or you are taking your CAS test, I am recording this set of notes so that you can have this for your reference and you can go through these notes yourself after you are done testing. So today we're setting up your flipbook. You already did that if you were in class, or if you were not in class, I set it up for you. You just have to make sure you copy down all these names, all these different names of the different notes that we're going to be taking. And we are going to be taking notes today on the second flap. So you have the first flap, which is the cover flap. And then on the second flap, where it says binary ionic compounds type 1, you're taking notes right on the front of that page. You're going to set up your page so it looks like this. So I kind of divide my page in half, and then I split the left half of the page into 3 parts. So I'm going to write about binary ionic compounds, naming type 1, writing ionic compound formulas, and then the right half of the page, I'm going to use the first half for practicing naming and the second half for practicing formula writing. So pause the video here so you could set up your page so it looks like my setup, and making sure that you are using the right flap where it says binary ionic compounds type 1. All right, hopefully, you have paused the video, and now let's go and talk about binary ionic compounds. So my joke for you today, the name's bond, ionic bond, taken, not shared. Get it? In ionic bonds, they take and they don't share electrons. All right, so here, binary ionic compounds. When a metal loses electrons to form a cation and a nonmetal gains electrons to form an anion, the resulting substance is called a binary ionic compound. Yes, you should copy down the picture. So underneath the header that you wrote, you're going to go ahead and copy down that sentence in the bullet point and the picture. In the picture, you can see you have an atom with a spare electron in its second orbital level, and you have an atom that needs an electron. So that atom with the spare electron, which happens to be lithium because it has 3 electrons, it gives it away, and it gives it away to an element that needs an electron to become stable. How does it need to become stable? It needs 1 more electron right here, so it has 8 in that shell, because 8 is what we need to be stable. Pause the video if you haven't finished copying, and once you're done, unpause the video, and I'll continue on. All right, under naming binary ionics type 1, let's talk about type 1 compounds. So in type 1 compounds, the metal forms only 1 type of cation. Type 1 compounds come from groups 1, 2, and 13 on your periodic table. They are the ones that we know the charges of. +1, +2, +3 charges. The metal forms only 1 type of cation with +1, +2, or +3 charges from groups 1, 2, and 13. They are very easy to name, and you name them using the ions. So first you name the cation, and then you name the anion. So for example, if I have sodium and chlorine, sodium is +1, chlorine is -1, they will combine to make sodium chloride. The big thing is that anion always ends in that suffix IDE. Let's see if I can pull up a text tool here. And yes, I do. I have the pen. And so that big thing right here is that you have to remember the anion always ends in that root word IDE. Whenever you hear IDE at the end, you know it's an anion, you know it's a compound. All right, let's trash that. Oh, no, not trash the video. Let's erase this. Okay, and want that tool anymore. We don't want that tool. Let's go to the next. Oh, we don't want that either. Cursor. There we go. All right. On the back of the front flap, I want you to write these common anion names. Most of them are pretty easy to understand. So you drop the ending and that regular ending, and you add the root IDE. Like fluorine becomes fluoride, chlorine becomes chloride, bromine is bromide, iodine is iodide. But some of them are a little weird, like nitrogen. It's not nitrogenide, it's nitride. Oxygen is not oxygenide, it's actually oxide. And then you have phosphorus becomes phosphide, and selenium will become selenide. If you had tellurium, it would become telluride. So I hope you get the point with how these roots end with the suffix IDE. So go ahead and write these on the back of the front flap of your flip book. So pause the video so you can go ahead and write this, and then we're going to go on. We're going to start learning how to write formulas and name compounds. All right, so now it's time to practice naming. So let's go ahead and copy down these 5 different compounds, and you might want to have a periodic table out so that you know what these elements are. And I'm going to go ahead and I'm going to pull up my text tool so we can practice. We'll go have practice with the pen so you can see me handwrite on the computer on the screen. So if I was to do letter A, CS2O, I'd find what CS is on the periodic table. CS is cesium, so I'm going to go ahead and write cesium. And then O is for oxygen, but oxygen doesn't say oxygen anymore, it becomes oxide. Notice that the second word, the second element, is going to be lowercase when you write this. Let's try letter B. What is Ca? That's right, it's calcium. Calcium. And N is for nitrogen, which becomes nitride. All right, CS2S. Again, we have CS as cesium. And sulfur becomes sulfide, not sulfuride, just sulfide. Li is for lithium. And Br is for bromine, which becomes bromide. And then finally, we have calcium for Ca, and fluorine becomes fluoride for F. So it's calcium, fluoride. All right. Take a moment to make sure you have all this written down, and let's go ahead and clear the text. And then we'll go on. If you missed this, here's the answers again, written a little bit neater because they're typed out. So pause the video, make sure you know that these names, and practice naming from formulas. All right, now we're going to do something a little bit different, and we're going to write ionic compound formulas. I want you to understand that when you do this, it's really easy to just switch the charges, but I'm not going to have you actually switch the charges like that. I'm going to show you how to do this using the proof because it makes a lot more sense. And I'm going to show you with some text too. So we're going to pull up the pen again. So if you look at the proof, you have a sodium atom, and there's 3 of them, and each of them has 1 valence electron. Then you have, oh, that's 8 right there, a nitrogen that has 5 valence electrons. Nitrogen has 5, sodium has 1. For nitrogen to be happy and balance out its charge, it needs to have 3 more electrons come and share with it. There's that last one right there. So it becomes a neutral atom, and it gains 3 electrons, has 8 valence electrons, and sodium goes back to being like neon by getting rid of that electron, so it's happy. The way this works is also represented using this crisscross method, and this is sodium nitride. But the way that this works and why the crisscross method works is because of the proof. If you have Na plus 1, and then you have N minus 3, you're going to need to balance those charges out. You want to know how many are going to balance out to make 0. You don't want any charge, you want this to be neutral. So you actually need 2 more sodium atoms, I'm recording, to balance it out. That way you'd have a plus 3 and a minus 3 charge to make 0. I hope that kind of makes sense, but we're going to go through this in the next slide. So there's the proof again. So it shows you 3 sodium atoms and 1 negative nitride atom adds up to make 0. All right, so let's practice formula writing. So go ahead and copy this down. So take a moment. All right, and then let's go ahead and pull up my pen tool, and we will practice formula writing. So it's really important that you have the charges of the cations and the anions in your periodic table. If you do not have them, I'm going to repeat them one more time. Group 1 is plus 1. Everything in group 2 is plus 2. Everything in group 13 is plus 3. Everything in group 15 is minus 3. In group 16 is minus 2. In group 17 is minus 1. And in group 18 is 0. So indium is in group 3. It has a symbol of In plus 3. And fluoride is fluorine with F minus 1. I need to have enough fluorines to balance out the charge. So I'm actually going to say I need 3 fluorine atoms to balance it out, because you have a plus 3 and a minus 3, which is going to give you In, and then you sum that up. How many fluorines? F3. And the little 3 goes behind that F. I just showed you the proof for sodium nitride, but let's do that again. So you have Na, it's in group 1 with the plus 1, and nitrogen, which is N minus 3. Plus 1 versus minus 3, you need 2 more plus 1 charges to balance out that negative 3. So you could put Na plus 1 and another Na plus 1. This is hard to write because I'm writing on a computer screen, but I think you get the idea. So you will have Na3 because you have 3 sodiums and 1 nitrogen, Na3N. Let's go ahead and let's clear these so that we can have some more room to write and do the next 3. All right, potassium oxide. Potassium's charge and symbol is K plus 1, and oxygen is O with a negative 2 charge. You have a plus 1 and a minus 2. You need another plus 1 to give you a plus 2 to balance out with the minus 2 to make 0. So that would mean you're going to have 2 potassiums and 1 oxygen in your formula. Let's do magnesium sulfide. Magnesium is Mg plus 2, and sulfide is S minus 2. Well, look at that. It cancels out. So I could just say there's one magnesium and one sulfur in my compound. So it cancels out because there's only 1 to 1, and then you don't have to write 1. Just like in math, you don't write, you know that if you have 1x, it equals x. Same kind of thing. All right, the last one, strontium fluoride. Strontium is Sr, and it has a plus 2 charge, and fluoride is F with a negative 1 charge. Yep, I'm going to need one more fluorine ion, to balance that out. So I will have 1 strontium and 2 fluorines in my compound. I hope you get the hang of this. Let me go ahead and clear this and show you the actual answers. All worked out. And once you have them copied, you are done for the day with notes. And it's time to start the digital practice assignment posted in Canvas. All right, guys, thanks for watching. Have a great rest of your day. Bye.